Okay, so as we see here, inverse functions effectively swap the x and y values. The x values of the function become the y values of the inverse function, and the y values of the function become the x values of the inverse function. So how would we get the inverse of y equals 3x minus 7? Well, we simply switch x and y to get x equals 3y minus 7. Then this equation gives y implicitly as a function of x. So y is implicitly a function of x. Explicitly, we could solve for y, and we're going to get x plus 7 over 3. Or if we wish, x over 3 plus 7/3. Okay, so this function could be written as f of x equals 3x minus 7. This function could be written as g of x equals x over 3 plus 7/3. What is f of g of x? Well, that's 3 times g of x minus 7, because we've replaced x with g of x. Of course, that's 3 times x over 3 minus 7 plus 7/3. I ran out of room, but then it's minus 7/3. Sorry, minus 7. And that's equal to what? Well, 3 times x over 3 is x, plus 3 times 7/3 is 7, minus 7, and that equals x. So f of g of x equals x. So that's a pretty good indication that we've got the inverse function. Now, we could also check out is g of f of x equal to x? Well, if we replace the x here with 3x minus 7, we're going to get 3x minus 7 over 3. And when we simplify that, we will end up with just x, and you should do that as an exercise. Now, these are two straight lines. You should also graph the straight lines and convince yourself that they reflect across the y equals x line. To do that, you have to use equal scales on the x and y axes. Mark the scales off carefully, make sure your units are equal on each axis, and that should work out. I recommend that.